walking on the trail to predict an incident to occur in future is really not an easy task. And especially when there's a will of God to play, the logic and math further cripples, and this problem sounds nearly impossible to solve. Natural disasters have been known to be one of the consistent means to cause loss of life and property around the world, and 2018 was no exception to this. Though it is not possible to completely avoid the natural disasters, but the suffering can be minimized to a great extent by creating proper awareness of the likely disasters and its impact by developing a suitable warning system, disaster preparedness, and management of disasters through application of information technology tools. This is exactly why in this video we have leveraged artificial intelligence to work in our favor and to predict the suitable possibility of a natural disaster much prior to its actual occurrence. We have leveraged the most recent and advanced kind of neural network for this purpose. In fact, our model has attained such comprehensive milestone in predicting a calamity, we believe that predicting the Kerala floods, the deadliest natural calamity of 2018, with 500 human deaths and 5.6 billion loss of property, could have been predicted if we had the required geographical data in place. So before we proceed and elaborate further on a solution, a very important thing to note here is that during a natural disaster, the primary device that forms the basis for all needs is a mobile phone. We have therefore opted to go for Android application as a primary device. It's not only the cheapest means of technology that almost every person in India has access to, but also the fastest means for a person to help themselves during calamity. Because let's be practical here, feasibility forms the most important basis for any solution. Now, in order to tackle all these situations, our Android application has been divided into 3 primary modules to obtain specific objectives. First, disaster prediction, second, offline services, and third, disaster management, all of which we will walk you through in this video today. Now let's get into what our team has built. Our application name is Epiphany, and firstly you'll be prompted with the splash menu. After this, you'll be shown a set of instructions which will give you a brief overview of what our app does. From here, you'll have to register yourself. So once you're done registering yourself, you can sign in. This is the homepage UI that caters to the disaster prediction aspect. This has been carefully designed to accommodate risk factors for your location. Each disaster card gives you a probability of the risk you have towards a particular disaster. For example, the cyclone disaster card tells me I'm 42% likely to face a cyclone in the upcoming days from my location, Surathkal, India. Let me explain you primarily how our AI prediction system for natural calamity works. Let's abbreviate this as AINCAPS for the sake of this video, which stands for Advanced Natural Calamity Prediction System. AINCAPS primarily has been divided into 2 aspects: prediction based on social media and prediction based on regional observational data that helps to provide a warning signal prior to the occurrence of the calamity. Now, while we're increasingly taking measures to ensure our prediction for social media gets better every day, prediction based on observational data is currently in research and development and has currently been implemented just for flood prediction, which we are readily hoping to expand further once we get the required infrastructure support in future. Okay, now let me show you first how social media prediction works. We extract information relevant for first responders from tweets generated during disasters in real time, as well as enable analysis after disaster has occurred. The pipeline consists of 3 parts: classification, clustering, and extraction. In the classification phase, we use a variety of classification methods, SVM and logistical regression, to identify tweets reporting damage or casualties. In the clustering phase, we use filtering to merge tweets that are similar to one another, and finally in the extraction phase, we extract tokens and phrases and apply NLP on that, which report specific information about different classes of infrastructure damage, damage types, and casualties, passing these to naive-based classifier for each specific event to get the disaster probability prediction value for region. And finally, this is how we get our prediction scores. Now let me explain you how prediction based on regional observational data works in case of a likely occurrence of floods. Now there are 2 parts to this. In order to accommodate the spatial indifference for the major causes of a flood, the coastal regions can be impacted due to a flood in a lot of different aspects than to an inland geographical place. Thus, we have used hydrodynamic models, which are an efficient and comprehensive approach to represent coastal dynamics to simulate the water levels, in addition to the geographical observational data for the coastal regions. Now, since the data based on these factors varies considerably with time, We have used a time-series neural network, the recurrent neural network, for our prediction. This recurrent neural network is fed with a variety of geographical inputs: the harmonic tide, the water level and surge at observation station, hindcast and forecast water levels computed by the hydrodynamic models at the observation stations, and residues from the observations, all of which is resampled on an hourly basis for a span of 3 to 10 years. The RNN is trained on 100 epoch cycles and 500 batch size with the two hidden layers to finally forecast the water level output. The trained recurrent neural network can further be leveraged to raise an alarm in case of an unusual rise in water level for the geographical place. We have obtained a cumulative mean square error of about 0.0124 on our training set and about 0.0099 for our test set. Thus, with InCaps, which combines the real-time prediction of natural disasters using social media and the prediction based on observation data from hydrodynamic modeling, not only stands out to provide a very comprehensive means to predict the natural calamities for major regions across India, but could have also been leveraged to predict the Kerala floods and significantly minimize its impact. The best part is, everything is incorporated right into your Android application, which makes it a very practical and feasible solution. Again, while we have incorporated this just for the floods, which is again under experimentation, we are currently conducting further research and development to further extend this to accommodate other highly occurring natural disasters impacting India. This again requires a lot of infrastructure support, especially for the intensive AI, and thus the Azure services provided by Microsoft would play a key role in taking our project further in future. Now, clicking on any of the disaster card gives me specific details on all the real-time data for the particular disaster happening or have occurred most recently. Clicking on any of the events gives me expanded information like the intensity, population affected, and the description of the disaster. We have also incorporated geographical information system for mapping analysis of natural disasters geographically. It provides live updates on natural disasters from a wide range of organizations and satellites to plot the result on a global map with detailed description at each point on the map. You can currently see in India major natural disasters and also further information regarding it. We have the offline services wherein we have the offline internet and the Wi-Fi mesh. So starting off, we have offline internet wherein we can access the internet via just text messages. So here we are inputting Microsoft, which it sends a request to the server mobile, which is received right now, and sends back a message to the client mobile after scraping the data from the internet via a boilerplate service. Now we have Wi-Fi mesh. Wi-Fi mesh is a peer-to-peer connection between mobiles and helps multiple mobiles communicate without actually having data connection. So as you can see here, discovery mode is on and it's trying to detect the mobile. The host mobile is trying to detect. Connected. Host mobile has detected the client mobile as well. And now we type in a message. The message is now received by the client mobile. This can be further extended to multiple mobiles, which can help form a mesh from which mobiles can connect without actually having a connection, thus facilitating communication being offline. So next we get on to the disaster management part of the application. So firstly is the AR zone. In a calamity-struck zone by red alerts disasters, AR zone provides a very efficient and prominent way of navigation by augmenting all kinds of places on the camera overlay, providing a composite view. This provides a holistic overview for the affected people by guiding them towards appropriate healthcare, food service, or shelter that may have got destroyed due to disasters. The user's bearing to and distance from each nearby location is calculated in real time as the device's location and orientation changes. Next we move on to our next feature, which is the volunteer shelter. Volunteer shelters help users who are safe and capable to volunteer their home as shelter. Other users can locate and get direction to the nearby shelters, and users can get to know if the family members are safe in some other shelter. The map provides you a holistic view of all the nearby shelters. and also provides a list of all the shelters nearby. You can also get direction to any of the nearby centers. The next feature we move on to is Find a Victim. Find a Victim helps us find people who are missing using the Microsoft Vision API. As you can see, we selected a person and it has been found in database. We have also incorporated a donation system to allow people from anywhere contribute to various kinds of commodities and post them on a common platform. You can either click on any of these commodities to view more details, or you can use a search engine to search for any particular commodity you prefer. You can also volunteer to donate any particular commodity by filling in the details of that particular commodity, as well as taking a picture and posting it on this common platform. Now, leaving no heads unturned, we also do have a blood bank incorporated in an application in case of severe situations. Now, you can either register yourself as a donor in case you would like to donate your blood, or as a requester in case you're in need of it. You can fill out this basic application form to register yourself as a donor. In case you would like to request, you can fill out the relevant details and get the concerned donors as a result. Clicking on any donor gives further information about them and also provision to call them directly from application, making the whole process more convenient. That's pretty much from our side, and we thank Microsoft CodeFunDo for providing us this opportunity. And this is Team You Know Who signing off.